a technological website that allows you to graph and then have these amazing visuals, and will make them easier for you to do. This is also helpful when you're doing your homework, so please use Desmos, and I'll go into detail about what that is in a moment. So then when you're doing your graphs, then that's going to be a visual representation for you, like as a board. Okay, so the definition, what does it mean to be an even function? An even function means, and we kind of discussed this already, it's even for every number of x in its domain. The number negative x is also on the domain. So if we have the value f of negative x, it should also equal the value of f of x. We're going to do an example. So an example of an even function. So f of x, let's say that's x squared. F of negative x is negative x squared, but this is x squared. Okay, so we get the same thing, meaning that x squared is an even function. A quadratic function is an even function. So when we have the point xy, the point negative xy is also on the graph, and it's symmetric towards the y-axis. That's important. Now, when you have an odd function, a function is odd if for every number of x in its domain, the number negative x is also in the domain. But now this looks different. Now the negative, instead of being on the inside, is on the outside. So look at the difference between even and odd. Notice that even it's inside, and then it gives you the same x. So a negative x and a positive x, a negative x, and then this is a negative y. This negative f of x is negative y. So an odd function, for every negative x, there's a negative y. The function is odd if and only if it's symmetric towards the origin. And we discussed that as well. So we're going to look at example number 1. And based on just looking at the graph itself, what can you tell me about them? This graph, it's symmetric towards the y-axis. See how this is the y-axis and it has a reflection. It's symmetric. This one is neither. It's not symmetric towards the x nor the y. You'll say, well, these are the same. But be careful. This is a positive and this is a negative. So this is not symmetry. And then last one, this one is symmetric towards the origin because it's symmetric towards the x and the y. Any questions on example 1? Just by visual. Just by visualizing whether something's even or odd or neither. Okay. So you want to be writing this down as we move along. Again, this is recorded, so at any point or time you need to go back. You're able to do that. Okay, so again, this is a function that is even. So let's do some examples of that. So we said an even function could be f of x is equal to x squared, x to the 4th, x to the 6th. Notice these are all even powers. Those are even functions. An odd function would be y equal, we have a y equal x, x cubed, the cube root of x. This would also be x to the 8th. Notice the difference between the two. This is an odd function. It's symmetric towards the origin, and the even is symmetric towards the y-axis. So let's try doing example number 2. Let me get rid of this, because I don't want to show you the solutions. I want to be able to do them with you. Let's look at example number 2, identifying even and odd functions from an equation. So what if you're not given a graph, but you're given an equation? How will you be able to distinguish whether they're odd or even? So use the definitions of even and odds to determine algebraically, meaning you have to substitute something, whether the functions are even, odd, or neither. To graph, see symmetry. So let's look at the first example. We have f of x is equal to x squared minus 5. How do we test whether something's odd, even, or neither? Well, we start by substituting x to be now negative x. That's how we start. So then we have negative x squared minus 5. Well, a negative squared, it gives you a positive squared, and this is a minus 5. Notice how the answer did not change. That means that f of x is equal to f of negative x. What does that mean by definition? So if we go back to the definition, isn't that the same as in even? And the answer is yes. So letter A is an even function. Any questions on letter A? How did I get an even function on part A? No? Okay. So how do I test if this is even or odd? Well, do the same thing. Now let g of negative x, and that's going to be negative x cubed minus 1. And we're going to test if this is even. So this is g of negative x. What is negative x to the third? That's a negative x cubed minus 1. Well, this is not the same as that. So this is not even because they're not the same answer. This is a negative x cubed minus 1. This is an x cubed minus 1. It's not an even function because we don't get equality. Well, so I think this is odd. Well, how do I test odd? It's the same, but now you let both, if you're testing odd, write this down. You're testing f of negative x is equal to negative f of x. That's what you're testing. So let's substitute x for negative x. So I'm claiming I have to have a negative g of x is equal to negative x cubed minus 1. So see how I let this be negative, but also x be negative? Because now I'm testing odd. So that's a negative g of x is equal to negative x cubed minus 1. So this negative, if I divide everything by a negative 1, because I want to go back to g, that's going to give me g of x is equal to x cubed plus 1. Wait a second. It's not the same, right? So this one's x cubed minus 1. This one's x cubed plus 1. So no. So this one's not odd either. So it's not odd and it's not even. So it's neither. So the answer is neither for part B. Because we tested both even and odd, and none of them give me back the same answer. So when I tested oddness, f of negative x, that's where I substituted the negative. Negative f of x is this negative g of x. When I divide everything by a negative 1, I get back x cubed plus 1, which is not the same as what I started with. Okay. So then letter B was a little more extensive because I had to do it twice. I had to do it for odd and even, and none of them work. So you will actually have to do that on your homework and on your test or your quiz for this section. And this is 1.3. Any questions on A or B?
I got one question. So for B, so if it's not even, then you test the odd right after, and then or you have to test the odd if you don't get a even
Yeah,
to try to figure it out if you
yeah,
could get it.
because you're trying to do a process of elimination. You saw it wasn't even, now let's try if it's odd. It wasn't odd and it wasn't even, well then the next case would be neither.
Okay.
You know what I mean? Yeah.
Thank you.
So we're gonna do that for the next ones. Okay. So then if I want to do the same thing, I want to repeat the process. I want to be able to find whether this is odd or even. Well, first of all, you want to also be smart in the way that you tackle a problem. This is a third degree. I know that that's not going to be even because it's a third degree polynomial, meaning it's an odd number of a third degree. So I know it's not going to be even. So I can automatically go to test oddness. That's over here. We saw a third degree polynomial. So in our mind, it said, oh, we can just test odd because I know it's not going to be even. On A, you knew it could be even because you have a quadratic, you have an even value of my function. Do you see what I mean by that? So because this is a third degree already, I know this is not going to be odd because that dominates. So what I'm going to do is I'm going to test for odd. I'm going to test for odd. I want to check if this is an odd function or not. So how do I test that? H of negative x equals negative h of x. So I'll start by saying, okay, negative h of x is equal to 5 times negative x cubed minus a minus x. I have to change x to negative x. Now here, I still have this negative h of x. Here I have a 5 times a negative x to the third. Okay, so negative x to the third is still negative x to the third. Here I'm going to get a plus x because two minuses become a plus. So then this becomes negative 5x to the third plus x, and then I have a negative h of x. The last step is I'm going to divide everything by -1. Why am I keep doing that? Well, because I didn't start with negative h's. I want a positive h, so I have to divide everything by -1. So this is h of x is equal to 5x cubed minus x. Wait a second. Isn't this the same as that? It is. So this is odd. This is an odd function. This is symmetric towards the origin. So because I'm applying the definition of what does it mean to be odd. Any questions so far on this one? So I didn't have to test for even. Why didn't I have to test for even? Because I already have a third degree polynomial. That automatically allows me to skip and testing even. Now letter D is different because I don't have any polynomial. It's just x. So how do I know whether this is odd or even? Well, I have to test. So let's start by testing whether this is even. Any questions, by the way, on part C? Okay. No? Okay. If you do, please stop me and ask questions if you have them. How do I test even? I apply the definition that says f of x is equal to f of x is equal to f of negative x. So here, my function will be now change x to negative x, but my function will stay the same. So it's going to say f of x is equal to the absolute value of a negative x. Who can tell me what the absolute value of a negative x is? It's just x, right? But the absolute value of x is also x. It's the same value. This function is even. A function cannot be even and odd at the same time, okay? It's either even or odd. Because we already found that this is even, it cannot be odd. Okay, so you're either one or the other. Is that clear, everybody? So letter D, we have an even function. We substituted this f of negative x to be the same as f of x. So we found that the absolute value of x is x, but the absolute value of a negative x is also x. So they're the same. So that tells me that it's an even function. That is for letter D. Okay, and then I'm going to scroll down. Let's talk about What does it mean to be increasing and decreasing? Let's talk about the definitions. So a function f is increasing on a particular interval, I, if the value f of x of 1 is less than f of x of 2. This looks weird, I know. All this is saying is once you have the value of x and the value of x2, the y1 and the y2 are decreasing. Okay, so the second one is bigger than the first. So you're having a positive, you're having an increasing interval. It looks like this. Increasing, you're going up, an upward interval. Now, when you have a decreasing interval, the second one is less than the first. So that looks like this. It's decreasing. It's going down. So this one's up and the other one's down. Or you can also do it from this way. Decreasing interval, where the second interval, the second choice is smaller than the first. Okay. You also have a constant. If all of them are the same, if you don't have any, if you have a constant interval, you're not changing. Your function's not either increasing or decreasing, it's just staying flat. So this one will say this one remains flat. So that's how that looks like. In other words, if a function is increasing, then the values as x get bigger, the function also gets bigger. Using the same idea, what happens if the function's decreasing? A function is decreasing when the values of x gets bigger, but the y values get smaller. What happens when the function is constant? Sorry. The value is function when it remains constant, when it remains the same. Okay. So what happens when the function is constant? So you have a flat surface. So there's no change. There's no change whatsoever. When you're constant, you're the same throughout the interval. So you're not bigger or you're not smaller. You're not going down or you're not going up. You're just staying flat. That's what this is saying. Okay. And we're going to look at some visuals so then I can help you and say, okay, well, which one's increasing, which one's decreasing, which one's increasing, or which one's constant. And we're going to do that now. Determine whether the function is increasing, decreasing, or constant from its graph. So let's do that. I want to get. So let's say that you're given this graph. I want to know, where is this function increasing? At which parts is this increasing? So notice how this starts down. From here to here, it's down. From here to here is up. And let me make this bigger. So from here to here is down. And then I'm going to change colors. This is going to go up. This red one, constant, and then it's going to go down. So I'm looking at, where is it increasing? What color is it increasing? Which one do you see the arrows going up? Where? From where to where?
-4 to -2, and then
Yep.
it goes up to -2 to 0, and then 0 to 4.
Right, so here it's actually only the x value. So yes, so it's from -4 all the way to 0 actually. So it's from -4 to 0. So it's always the x values when you're looking at increasing or decreasing. So I'm starting at my x value being -4, And this is going up. So it doesn't stop at -2. It keeps on going up, you see? And it stops at 0. Where is it decreasing? It's decreasing from -6. And then it stops at -4. And then again, a union. This little U thing is, it means that I have more decreasing intervals. From where to where is it decreasing? From which X values? So I already have the first one from here to here. Where is the other ones?
3 to 6.
Thank you, Michael. From 3 to 6. And that's my answer. Now, the last one is, where is it constant? From where to where? From which X values? And it's the red one. It's constant. See how nothing is changing? These arrows are being constant from 0 to 3. So from here to here, my graph is constant. From my X being 0 to my X being 3. From 0 to 3. So just by visualizing, so down, up, and then constant, and then down, and then up. Okay. Any questions on example number 3? Example number 3. Remember, it's always the X values. So you're not looking at the Y values. You're only looking at the X values because it's an interval. Okay. Warning, we describe the behavior of a graph of its X values. Do not say above it's increasing. We rather say it's on the interval between -4 and 0. And they have a closed dot. Normally intervals are always open. So you keep them this way. So it depends on the textbook. So some of the textbooks use brackets to define intervals, some of them open, the majority use open parentheses. So the ones that I have, that's the correct notation. However, it depends on the textbook. Maybe they want a closed interval. Okay, so be careful with your homework assignment. Sometimes it's going to ask you for a bracket or a parentheses. So you could see it both ways. So see how I have -4, 0, and then 4, 0. The difference is a bracket, oops, versus a parentheses. So this closed dot, it means the bracket, but the interval is the open parentheses. So it depends on how your textbook wants it. So let's assuming that you did it, you're doing your homework and it marks the parentheses incorrect, that means they want the bracket. So you just have to test it out. So sometimes they want one thing, sometimes they want the other. Any questions on that? Because your homework can get picky, and you know that already. Okay. Now let's look at the other one. Use the graph to determine whether the function is increasing, decreasing, or constant. Let's try this one on our own. So let's look at this graph. Let's answer the question. On what intervals is the function increasing? Don't answer that yet. You always start by doing your arrows, and it's always from left to right. I'm always starting on the left side. So this is going down. Then it's going to go up. Then it's going to go down. Then it's going to go up again. That's how you start and do your arrows from left to right. If it starts up and then it goes down, that means it's decreasing and increasing, then decreasing, then increasing. So I want to find where is it increasing, and I'm looking at the X value. So here and here. So it's increasing from, who can tell me the first part? From 0 to from here to
1.
Yep, to 1. So from 0 to 1, union, because I'm not done. from where to where? From 2 to infinity. Why infinity? Notice how this has arrows. That means it goes on forever. This little arrow business, it means it's going forever. Any questions on part A? Okay. Part B, on what intervals is the function decreasing? It's going down from negative infinity because we start up here. It starts from negative infinity on the X, and then it stops at 0. Union, where does it go down again? From where to where? From which X values?
1 to 2.
Thank you, Michael, from 1 to 2. Now, where is this function constant? Does it stop at some point? And the answer is no. There's no constant interval here. There's no way that this stops somewhere like the one that we had. So up here, there was a stopping point right here. But on this one, there's no flat surfaces, right? It's not constant. There's no flat surfaces. That's another key to how to find a constant, an interval where it's constant, where, well, there's no flat surfaces. So then there's no constant interval. What is the function's domain and range? So let's talk about that. What is the domain? The domain is all of the possible X values. What are the values of X that you see? Well, this is from negative infinity to positive infinity. That's the domain. The range, it's the lowest to the highest point. So the lowest point on your on your Y value is 0. Your range is from 0 to infinity, including 0, because you are allowed to be 0 on your Y. So the lowest point is 0, the highest point is infinity on your range. So your domain is all X and Y values, so from left to right. There's no restrictions on your left, on your right. The bottom, you can't notice that this is never below 0. My graph doesn't live here. So my range is from 0 up, from 0 to infinity. It doesn't start at 1, it starts at 0, because you have a point right there. Okay. Any questions with domain and range or this example number 4? Okay. Please do ask questions if you have them. Okay, that's fine, Zakia. It's all, the link for this class is always. Let me answer that question, Vicky. So the domain and the range can use brackets and parentheses mixed together. So the parentheses will always go where infinity is. You will never have a bracket with infinity. Why does this one have a bracket? Because there's actually a point there from 0 on. So this point was 2, 0 and 0, 0. That means 0 is included in your function. So then from 0 to infinity, that's why the 0 has a bracket. Zakia, the Zoom link, it's always the same one, and it's back either in week 2 or on the first day of class. I always have that link there. So it's always going to be the same link. Okay. Alrighty. Let's talk about minimum and maximum points, local maximum and local minimum. So a local maximum and a local minimum is where a point lives. So for example, this example that we have on the first one, these points are called local minimum. Those are your minimum points. It's a local. And this point up here is your local maximum. You can't touch the top ones. Those are not actual points on your graph. So these two will be local minimums. And this highest point is your local max. Because that's the maximum point you can locate. That's why it's called local. It's within an interval, which is not the same. So see how these are the lowest points and this one's the highest point? That is called the local max and the local min. So we're gonna use a graph to locate the local maximum and the local minimum. You can have more than one local maximum or local minimum. So let's look at this one. Use the graph to locate local maximum and local minimum. At what numbers, if any, f has a local maximum? At x value being 1, at y being equal to 2. So at what numbers, they refer to the x values. So when they say at what numbers, they're referring to the x. When they're referring to the local maximum is your actual y value. So the local maximum point would be at y being 2. Okay. Same thing with letter C. At what numbers it has a local minimum? So we noticed that the highest point was 1,2. There's 2 local minimums. You're gonna say, oh, well, this one's the lowest point, so this is the local minimum. Yeah, but I'm talking about a particular interval. So there's one piece right here, there's another piece here, and another piece here. So this one's a local minimum at this point. This is the local maximum at this point, and this is another local minimum at this point. So at x being -1 and at x equal 3, I have 2 minimums. Which one? What is the minimum? At y value being 1 and at y value being 0. This x3, 0, that corresponds to this minimum, and -1, 1, which corresponds to the other local minimum. Again, you can have more than one. Any questions on 5?
Yeah, I'm a little confused.
On what
How
part?
do you, I guess I'm still stuck on that. How do you have 2 local minimums when I'm looking at the chart and one of them is
One is
Smaller.
smaller than the other. I'm not asking for the absolute minimum. If I would say the absolute, there's that which we're gonna get to. You look at the lowest point. So I have a low point here and a low point here. They're local. At a local region, if I'm just looking at this portion. So let's assume that we're looking at this interval from here to here. This would be my minimum point, and this would be my max point. You would see, do you see that, Walter?
Yeah, I'm tracking.
And then what if I'm looking at it, this interval? I have a maximum here and a minimum here. That means I have 2 minimums at a different location. If I'm looking at the whole interval itself, that means I have 2 local minimum values. And 1 maximum. This would be my max, my local max. And these 2 will be my local min, because it will be an absolute minimum here and here if they were separated. But because it's the whole thing, I have 2 of them. Again, there could be more than, so see up here, we had 2 minimums. You're gonna say, well, yeah, but they were both 0, right? But if it would be a little bit higher, like here, it would still be 2 local minimums. Walter and everybody.
I get what you're saying. I guess looking at the other definition, because they were equal, I was thinking we counted both of them because of that. But we're talking about in 2 different areas.
Exactly.
I'm with you now.
Perfect. Exactly. So see how we have the y value is the local maximum and minimum. So it occurs at some x value. So again, when they ask for the local maximum and minimum, they will ask for the y value. So here, the local minimum was at y equal 1 and y equal 0. But if they ask at what numbers, they're referring to the x values. So just be very careful on how they word the question If they ask for what numbers, they're referring to the X values. If they're actually referring to the actual local max and min, they're referring to the Y values. So just be very careful when you're answering these questions on your homework, because they kind of trick you. So just, I'm letting you know in advance. And let me put this to charge. So as you write that down, I'll put this to charge. And then I'll scroll down. Now, as I was mentioning, there's also called the absolute. So while it's possible to have, so let's read that. As it's possible to have multiple local max or mins, there is only one absolute. And that's what I was referring to with Walter. The absolute maximum or the absolute minimum is only one. There's only one of them. It's going to be the lowest one or the highest one. That's it. There's no more than one absolute. This notation, the definition can get kind of funky, so just be careful. I'm not going to ask you for the definition, so this is for you just to fill this out. That's not going to be on your exam or your quiz or anything. It's just for you to have as a definition. What they really care about is when you look at the graph itself. So we're going to look at example 6 to kind of help you find whether an absolute minimum or absolute minimum or maximum exists. Sometimes it doesn't exist. Okay. So when we look at this graph, I see this is increasing, and then it has a point right there, and then it decreases, and then it's constant, and then it goes down. And then it goes up. And because I have this arrow, that's where I have to pay attention to. They're asking me whether there's an absolute maximum in the problem. And the answer is no. Why is there's not an absolute maximum? Because this interval, this graph, goes to infinity. We don't know what that point is. There is not an absolute, there is a local. The local max would be this one. This would be a local max, but not the absolute. This is a local maximum. Now, there is an absolute minimum. Why is this an absolute minimum? You're going to say, oh, well, look at this. Look at the starting point right here. The starting point is at my Y value being 1, but there's something else. There's a 0. At X being 4, my Y value is being 0, and then this goes to infinity. So the absolute lowest point is going to be when my X is 4 and my Y value is 0. So this point is the absolute minimum point. Okay. You could say you have local minimums. Okay. This can be 1. This is a constant. So from here to here, it'd be constant. So they don't count. But the absolute minimum point would be at this value. Okay. Similarly, if we look at the next one, see how this one is up, and then there's a point, and then down, and then up, and then down again. The minimum, there is no absolute minimum value. Why? Well, because they are always decreasing. No absolute minimum, because it's always going to negative infinity. Look at the arrows. But what about, they're going to negative, but what about the absolute maximum? What is the highest point? The highest point is when my Y value is actually equal to 2. And the X, at what locations? Well, at X being 0 and X being 2. But remember, I don't care about the X, I care about the Y if I'm looking for the absolute max and min. So the absolute maximum point is at my Y being 0. Sorry, at my Y being 2 right here. So I'm looking at this one. at my Y value being, so the highest point is this one. That is called the absolute maximum value in this graph. Any questions on the first or the second? And remember, there's only one. So the absolute max was at Y being 2. There's an absolute min at Y equals 0. So here, let me remove this. You'll say, okay, well, which one is the absolute maximum point? And you'll say, okay, well, the maximum point would be at Y being 5. But there's something there. We have an open dot. It's not part of it. 5 is excluded. So because it's excluded, this doesn't count. But what about the absolute max? Sorry, absolute minimum. So the minimum value, is it this one or this one?
The one on the right.
Yep. The minimum value is at Y being -4. And this one is included. The top one would be a local minimum. But there's no max because this is an open dot, so you need to be very careful. Okay, so make sure you're writing that down in your notes. So again, if we are looking at this one, if we want an absolute maximum and absolute minimum, just by looking at this arrow, there is no absolute max. Because it goes to infinity. What about the minimum? What's the minimum point? Absolute.
0.
Yep. So there's an absolute minimum at Y equals 0. Remember, it's always Y, at Y equals 0. Any questions on this graph on example number 6? So make sure that you're looking at your arrows. Now remember, these notes are found in the latest announcement. The notes are right there. Let's talk about the extreme value theorem. There exists a theorem that it states if f is a continuous function, meaning it doesn't have holes, it doesn't have any gaps, it has smoothness, is continuous, whose domain in a closed interval, AB, f has an absolute max and an absolute min. So there is a guarantee to be an absolute min or an absolute max. So let's look at example at the definition. With the extreme value theorem, the absolute max or min can be found by selecting the largest, which you know, the largest of the following list. The value of f has any local max and min within an interval. The value f of each endpoint, that is f of a or f of b. That's actually when you substitute f of a and f of b. So if we look at example 7, notice that the third graph of example 6 is continuous over a closed interval. So they're talking about the third one. So they're talking about this one. There is a closed interval from -2 to +3. And that means that when we substitute, we knew that we had either an absolute max or an absolute min. Why? Because there's a closed interval. So if look at all of the rest, this is not a closed interval because this goes off to infinity. The other one also goes to infinity, and this one also goes to infinity. The only one that did not go to infinity was between -2 and +3. And there is a guarantee to have either an absolute max or an absolute min. That's what this theorem is saying. So if you have a closed interval, you are guaranteed to either have a local max or a local min. So in this case, we found an absolute minimum. Any questions? So this is just a theorem that says if you have a closed interval, then you're guaranteed to have an absolute max or an absolute min, whatever it is. Or you can have both, one or the other, or even both. Okay. So we're gonna use this. We're gonna use Desmos. I'll show you how to do that. So when you get to your homework and you get to a question that looks like this, use a graphing utility to locate or find the local max or the local min for, and I want to make sure that I'm only looking at this interval from -2 to +2. So let's go to, and this is not a closed interval, it's actually an open interval, but let's go to our Desmos. Let me share my screen. So I want to show you how to get there. So let's go to desmos.com/calculator. Let me share that screen in a moment. So it looks like this, desmos.com/calculator. And you're gonna say, okay, I want the f of x, just put y equal. That's the same as f of x. Is equal to 2x. And then see how they have this little cursor thingy business? You can use these functions or use the caret to write it a third power. So what I did was a 2x and then I did shift and then the caret. And then I did 3, oops. And then move the cursor to the left and then put -3x and then put my +1. And I'm only looking between this -2 and +2. And what can you tell me about it? How many local minimums do I have? We actually have a couple. So you have a minimum point, you have a minimum point, a minimum point, and a minimum point. The only highest point would be 0 and 1. So see how I have multiple local minimums at -1. So at this value, I have a local minimum here, here, and here. The only one that's the highest is 0, 1. And I'm missing another one, I'm lying. This one is another, this would be, remember, because it's an open interval, okay, it's not a closed interval. They will only have local. So this is a local maximum, a local maximum, a local minimum, local min, local min. Okay, so at different places, you will have where it's increasing. It also asks for where is it increasing and where it's decreasing. So we found our minimum values right here at 0.3660, at this point right here, which is 1, 0. And then this one's also a minimum right here, a 0.70, comma, I think this is a negative radical 2. Okay. So here are our local minimums and our maximums right here. This is a local max and this is also a local max. Any questions on this one? On just local max and local min? Because we're gonna look at increasing and decreasing next. So I'm gonna take a picture. So I'm asking for where is it increasing and decreasing? Notice how this is going up. I wish I could do arrows. I think I can. Annotate. Yeah, that's what I want. I'm gonna draw. So notice how from here it's going up. Oh, I want arrows. Up, 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 all the way over here. And then it stops at one of these points. I want to find what that point is. Let me close this and then let me actually pinpoint it. That's the point that I want. I'm gonna ask for them to label. So it stops at negative 0.07. So it's increasing from -2, sorry, for here from -2, because that's our starting point. Remember, we're only looking at an interval from -2 to +2. So it starts at -2 and it goes up, 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 and then it stops at negative 0.07. And then it goes down. I don't want decreasing, I want increasing. It goes up again from here, 0.07 all the way to 2, because it stops at 2. So it's increasing from -2 to negative 0.707, and then it's increasing again up here. And where is it decreasing? Well, from negative 0.7 to positive. So see how the only location where it's going down, it's right here. Okay.
I found this on the web.
So let me go back to my notes, so then you can see it. So it's increasing from negative infinity to negative 0.707, and then again union from 0.707 comma 2. And it's only decreasing at an interval at negative 0.707 comma 0.07. So this one, it's only at one location. This one's 2. It's increasing in 2 locations and it's decreasing in 1. And these are only my X values. Increasing, decreasing are only the X values. Okay. Any questions on problem 8? So again, when you're asked to do this on your homework, make sure you go to Desmos and then you could see the locations and everything. Okay. So please, and I'll actually add that when, I'll send you guys a reminder when I publish this recording. I'll say, please don't forget to use Desmos, because that's going to be highly used in this class. And you're going to be able to do that on your homework, and on your exams. Moving on to, what is an average rate of change? You've seen that in the past already. Actually, the average rate of change is actually your rise over run. It's your slope. It's f of b minus f of a divided by b minus a. So that is the formula that you want to write down, where a is not equal to b, because then my denominator would be 0. So let's be careful there. So we're gonna find average rate of change between 2 different functions. And you're gonna be asked to do this on your homework and on your quiz next Tuesday, right, when it's due. Walter, I replied to your email.
Yeah, I got the reply. I really do appreciate it.
Okay. I'll do that when the class is over, okay?
Okay.
Okay. Alrighty, so let's look at how to do average rate of change between a function. And all we're gonna do is we're gonna use that formula. So if we're looking at the average rate of change between 0 to 1, and this is the function. So the function f of x is equal to 1/2 x squared. So what is this saying? I have to find, okay, well, a is the lowest. So this is an interval between 0 and 1. Okay. So the a is 0 and the b is 1. So we have to find f of 1 minus f of 0 over 1 minus 0. I'm applying the formula that I just saw. F of b minus f of a, f of b minus f of a over b minus a. So the function that I'm going to use is this 1/2 x squared. So f of 1, it's going to be 1/2 1 squared. So that's 1/2. f of 0, I'm going slow, is 1/2 times 0 squared, which is 0. So then when I substitute f of 1 and f of 0, I have 1/2 minus 0 all over 1 minus 0. And that's going to give me 1/2 divided by 1, which is the same as 1/2. So the average rate of change of the first one is 1/2. So let's recap. I started by identifying who is A and who is B. A is the smaller number, B is the bigger number. So then I apply the formula f of B minus f of A divided by B minus A, which is this one. F of 1 minus f of 0 divided by 1 minus 0. Then I have to find what f of 1 is. What is f? Well, f is the function, 1/2 x squared. So it's going to be 1/2 times 1 squared is equal to 1/2. 1/2 times 0 squared, because that was A, is equal to 0. Now I have to plug those in right here. 1/2 minus 0 divided by 1 minus 0. That's 1/2. 1/2 over 1 is 1/2. Any questions on part A? I will do part A and part B, and you will do part C. So let's do part B on our own. So again, who is A and who is B? So in
A
this
is,
case,
A is
Yep.
0, B is 3.
perfect. So then I have to find f of 0. But didn't I already do that? Didn't I already know what f of 0 is? Yeah, f of 0 is 0 without having to do anything because we're using the previous. We already did f of 0 over here. We know that f of 0 is 0. And let me move this a little bit to the side so you can see it. So we know that f of 0 is 0. So f of 0, f of A is 0. Now f of 3, what is f of 3? It's 1/2 times 3 squared. But what's 3 squared? That's 1/2 times 9, which is 9/2. Okay, well now I have to do f of 3 minus f of 0 over 3 minus 0. So what's f of 3? F of 3 is 9/2 minus 0 all over 3 minus 0. So that's 9/2 divided by 3, or multiply it by 1/3. So what I did is instead of dividing it by 3, I multiplied it by 1/3 so I can simplify. So basically this is 9/2 divided by 3, which is the same as 9/2 times 1/3. Now, what does this mean? I'm going to simplify 9 and 3. 9 goes into 3 3 times, 3 goes into 3 1 time. So this is 3/2. Make sure you simplify all the way. So what I did was I simplified the 9 into 3. They're both divisible by 3, so they simplify as 3/2. Are you ready to do C on your own? I'll help you set it up. You have to find, so I know that A is 0 and B is 5. You have to find f of 5 and f of 0, but you know this one. You know that f of 0 is 0. What is f of 5? Go. How do I find f of 5? It's going to be 1/2 times 5 squared. What is that? (25 over 2). So then you do f of 5 minus f of 0 divided by 5 minus 0. You know that f of 5 is 25 over 2 minus 0 all over 5. So it's 25 over 2 times what? What's the trick? Instead of dividing it by 5, I'm going to multiply by what? What did I do over here? I made this 1/3, so what is this going to be? 1/5, right? I simplify 25 and 5. And this is going to be 5/2. Any questions on A, B, or C? This is called average rate of change. Average rate of change. Questions on this one? Okay. So what does the slope of a secant line mean? The slope of a secant line is the average rate of change from A to B that equals to the slope of the secant line containing 2 points, x equal A and x equal B on its graph. So basically what this is saying is, you are going to be finding the secant line or the slope of the line, okay? So given an equation, you're able to find the slope of that equation of a graph between 2 points. And that's what we're going to be doing next. So let's get rid of that. So the first thing that you need to do is apply that formula. And it's saying from -2 to x. So this -2 is A and this is B. So we first need to find the average rate of change, and it's going to look complicated. So we're going to do the same thing that we did for above, but now for an equation. -2x² plus 4x minus 3. So we need to find an average rate of change equation for G. So we start by, well, G of A is the same as G of -2. So let's plug that in. So that's -2 times -2 squared plus a 4 times a -2 minus 3. I'm applying that to this equation. I have to let A be -2. So I'm substituting that in here. So then that's what I'm going to get to be -2 times 4 minus 8 minus 3. So that's going to be -8 minus 8 minus 3. So it's a -16 minus 19. So here we have a +4 squared and then but a -2. That's going to give me a -8. So a -8 minus 8 minus 3, it gives me a -19. So -19 is G of A. So G of -2 is -19. Now I have to do G of X. Well, you already know what G of X is. G of X is -2x squared plus 4x minus 3. So what do I have to do? I have to do G of X minus G of -2 divided by X minus 2. X minus 2. We have to be careful because minus 2. So this negative comes from your A, and this negative comes from the formula. Okay, so be careful there. So we know what G of X is, and we know what G of 3 is, like so. So we have to combine them. So G of X minus G of -2 is going to be equal to -2x squared plus 4x minus 3 minus a -19. So then what is that going to happen? So we're gonna clean it up, and that's gonna be negative 2x squared plus 4x minus 3 and a plus 19. So it's a minus 3 and a plus 19, that's a plus 16. Divided by x minus 2. And this becomes a plus actually, because you had a 2 minuses here. I have a minus and a minus, that's gonna give me a plus 2. This nastiness is the actual rate of change from -2 to x after cleaning it up. So it took us a long time to identify, okay, now that I have an equation, I have to plug in -2 for g, and I get -19. But then I have to plug in an x, which is -2x squared plus 4x minus 3. Now I have to subtract them because that's what the equation says, g of b minus g of a. That gives us -2x squared plus 4x plus 16, because I combined -3 and a positive 19, divided by b minus a. B is x, a is -2, but 2 minuses give me the plus. So now, finally, now that I have this, use the results in part A to find the average rate of change from -2 to +1. Okay, well, now what this is saying is, now that you have the equation, I want to find the average rate of change between -2 and 1. So there's 2 ways I could do that. I can directly substitute it into G. So I could do what's G of, so this is A and this is B. I can do G of 1 minus G of -2 over 1 minus -2. And then I can substitute. So G of 1, after plugging it in from -2 to 1, I can just go ahead and substitute it. So I'm going to do that. So G of 1, if I plug it in, because that's G of B, it's going to be -2 times 1 squared plus 4 times 1 minus 3. That we already did something like this, very similar. -2 plus 4 minus 3. -2 a plus 4 is a +2, minus 3 is a -1. So G of 1 is -1. We already know what G of -2 is. G of -2 is -19. So it's a minus -19 all over 1 plus 3. Oh, sorry, 1 plus 2. Negative and a negative. So if I combine this, this is a -1, oops. -1 plus a 19 over 3. But that's 18 over 3, which is 6. So 6 is the average rate of change between -2 and 1. Okay, after substituting. Okay, this might, how do you guys feel? You guys are so quiet. That scares me. So are you guys good with this, or is it too much, or how do you feel? I want to know the temperature of the room. How do you guys feel?
So, I mean, I think for me, I mean, the function stuff is just, I think that makes the most sense to me. After seeing it, it just looks like you're just plugging in an input and then you receive an output and then you just kind of go work out the math, right?
Exactly. Anybody else? But I mean, that's for Ariel's perspective. Does anybody else have a different perspective, a different take? How do you guys feel? If you feel comfortable in the chat, you could do that too. Okay, so some of you are feeling well. Okay. I just want to know that we're doing okay, hopefully. Because I want you to be able to excel when you go to your house and do your quiz. And I know it can get frustrating a little bit, going back and forth. But I'm here to help. Okay, so let's look at the secant line, which we knew it was 6. So let me get this through. So what they want us to do here in this problem is to find an equation of the secant line containing these points. So for example, this point is -2 comma -19. We found that G of 2 was -19, and then we have 1 comma. When we plugged in 1, what did we get? We got -1. And we found the slope of the line. We found the slope or the average rate of change. Which was the slope to be equal to 6, right? We did that in the previous part. Now they want us to find the equation of, sorry about that, the equation of the secant line. So when you're trying to find the secant line, if you remember, you guys did this already in F1 through F4, and that was using the point slope form. So that's what we're going to be doing when we're asked to do the secant line. You use the point slope form. What is the point slope form? It's y minus y1 equal mx minus x1. So in this case, this is going to be x1, y1, x2, y2. And what is the slope? Who can tell me what the slope is? It's right there. What is the slope? Anyone? What is the slope of the line? And I see it on the chat. Yep. C. And the answer should be 6. It's right here. So 6 is the answer for the slope. Now we just have to plug in x1 and y1, which is right here, which is this one. So we do y minus y1, which is -19, is equal to m, which is 6, x minus x1, which is -2. And then we clean it up. We get y plus 19 equals 6 parentheses x plus 2. Clean it up and write it as a slope-intercept form. So we get y plus 19 equals 6x plus 12. And then we bring the 19 over, y equals 6x plus 12 minus 19. So the secant line is y equals 6x minus 7. Okay. So 6x minus 7 is our answer for letter C. That is the secant line. So see how everything goes back to something that you learned already? So it's the point slope. So what we're going to do is we're going to use a graphing utility to graph the function g, which is this quadratic. And then we're going to use the Desmos to find the secant line. So we know both the g and the secant line, and we want to see how that looks like in our graph. So visually, we want to have a visual representation. And the way that we're going to do that is using Desmos or technology, as what they say. So I'm going to start in Desmos again. Everybody can see my Desmos screen, folks? Yeah? Good.
Yep.
Thank you.
Yep.
So then we'll start by having y equal, we're putting in our function -2x parentheses, and it's a squared. And then we have a plus 4x minus 3. So there's our equation. There's our function g. And then we have our secant line, which is 6x minus 7. See how this crosses my secant right there at -1, 1. And then again over there, down here, it crosses again at negative. Oh, aren't those the 2 points that we had? 1, -1, -2. Sorry, yeah, -2, -19. Yeah, those were the 2 points that we found. So based on 2 points, we can find an equation of a line using the point slope form. And we found the slope. And that is the end of section 1.3. We are going to go to section 1.4 next. So 1.4 is kind of nice. 1.4 is actually the library of functions. So we're going to go over a few functions here in this class, in this section. And then we're going to be talking about what is a piecewise defined function. So in the real world, seldom can be data represented by just one function. More often, data changes over time and must be represented by many different functions. When a function is defined by different equation or parts of its domain, it's called a piecewise defined function. Before we look at a piecewise function, we must make sure we are familiar with a lot of different functions, and we call them library of functions. I actually call them mama functions. It is important to know the properties of each functions here. Being able to visualize basic functions will help you in later topics such as nonlinear systems and graphing using transformations, which is another thing that we're going to do. So let's do an exploration. The basic function that we start with is the identity function. What is the identity function? It's when we have a line, y equal x. So if we have the values of x, well, guess what? The values of y will be the same because y equal x. So if I graph that, the point is going to be 0, 0, and then 1, 1, but then it's negative 1, 1, 2, negative 2, negative 2. See how I have all these points? This line is the y equal x line. And we're going to talk about the properties. What is the domain of this line? Where is from the left to right? The domain is from negative infinity to positive infinity, from left to right. The range is the lowest to the highest point. The lowest point is negative infinity. The highest point is infinity. The lowest to the highest. What are the x-intercepts? Well, 0, 0. The y-intercept is also 0, 0. This one is an odd function. Okay. So negative x and then negative y, but it's also, so if it's an odd function, right? This is an odd function. It's symmetric towards the origin. We also have, where is the function decreasing? Where is this going down? Well, be careful. You always start from left to right. So you have a person here and it's climbing up. So none. There is no interval where it's decreasing. This one's always going up, uphill. If it would start up here and then go down, this will go downhill, but it's always from left to right. So you can't put your guy over here and say, oh, it's going down. No, it's always from left to right. So there is no interval where it's decreasing. Where is it increasing? It's increasing from negative infinity to positive infinity. It's always going up. What about the local maximum and minimum? It doesn't have one. See? And you'll say, well, the minimum is 0, 0. Well, be careful because it has this infinity. This when you have these arrows, you don't have any max or any min. It goes on forever, so you don't have any. Any questions on this identity function? Just, that's the first function that we see. Questions? Okay. This is a quadratic function or the square function. This is also called a quadratic function, y equal x squared. So if I have my x to be negative 2, so y equal negative 2 squared, that's positive 4. If I have negative 1 squared, that's 1 right here. I'm substituting 0. I get 0 when I have a 1. I'm 1. When I'm a 2, I'm a positive 4. So how does that look like? I have a point here at 0, 0, 1, 1. -1, at +2, I'm 4, at -2, I'm 4. So my graph of an x squared looks like this. So my domain is from -infinity to +infinity, from left to right. And it has a parabolic shape. See, it looks like a U shape. The range, look at how this is a bracket from 0 to infinity. The lowest point is 0. The lowest is 0 and up to infinity. Bracket including 0 to infinity. The x-intercept is at 0, 0. The y-intercept is also at 0, 0. It's symmetric towards the y-axis because this is an even function. So if it's an even function, it's going to be symmetric towards the y-axis. We learned that. Where is it decreasing? It's going down from -infinity and it stops at 0. Where is it increasing? From 0 to infinity, like so. Where is it decreasing? Where it's increasing? The local maximum and minimum. Well, that one, because you have, even though you have, notice how we have arrows here and you'll say, okay, well, this is none. Well, because there is this symmetry going on that forces this to be a local. So let me get rid of this. Well, technically, this is the absolute as well. Remember, when we're a local maximum or an absolute, it's the y value. So the lowest point of this graph is actually at y value being 0. So when your x is 0, but your y is 0, it's both the local and the absolute. Okay. Any questions on this one? The quadratic function? So this is just to talk about and to be familiarized with the functions that we're going to be studying across the semester. So we have a linear function, which is y equal x. Then we have a quadratic function, which is y equal x squared. And then we look at the properties. And then look at this one. We have the cubic function, y equal x cubed. Now what happens when x is -2? -2 raised to the third power is -8. -1 to the third power is -1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. So if I graph that, at -1, I'm -1. At -2, I'm down here. -2, -8. Here I'm at 0, 0, 1, 1, and then 2 all the way to 8. So it looks like this. So again, what is the domain? The domain is all the possible x values. You don't have any restrictions. So you're -infinity to +infinity. The range, what is the lowest point? The lowest point is -infinity. The highest point is infinity. The x-intercept right here, 0, 0. The y-intercept is at 0, 0. Your symmetry, it's towards the origin. How do I know it's the origin again? Because this is an odd function. It's an odd function. This is a y to the third power. May I have your attention, please? If you need. So on this one, the interval is decreasing where? There's no place where you're decreasing. It's always going up. So there's no way that you're decreasing, and it's increasing everywhere from -infinity to positive. So remember, we start from the left, we go to the right. where is the local max and the local min? Well, technically you don't have one. I put in 0, 0, but 0, 0 would be your local in reality. That'd be the only one, and this one doesn't have any. So see, look at the arrows. It doesn't have a stopping point. It has a local, it has many locals. The absolute, you don't have an absolute because this goes on to infinity. The lowest point, the highest point, you don't have one. So there's no absolute maximum or minimum. But you can have a local at 0, 0. Okay. So that is a cubic function. You have symmetry against the origin because it's an odd function. Those are our x-intercepts, our y-intercepts, the domain, and the range. Okay. We have the square root function. The square root function looks like an arrow. So an arrow looking like. We'll have a break at like 7:45-ish, 7:50. I'll send you guys a reminder. We'll say, oh, we'll go on break and then we'll come back. So if we start by substituting -4 into here, why does it say like a 0 and a cross? Because you're not allowed to be a negative inside a square root. -4 here, it does not exist, G and E. We don't have anything here. We don't have anything here. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. So see how my starting point is at 0? What would be the other one? The square root of 9. The square root of 9 is 3. So this looks like an arrow like that. So the domain is, what are the possible x values? The x values are from 0 to infinity. The lowest point could be 0 to infinity. The range is also from 0 to infinity. So from left to right and down up, the lowest point is 0. Your x-intercepts are at 0, 0. Your y-intercept is also at 0, 0. Does it have symmetry? No, there's nothing here, right? It's not symmetric towards the x, not symmetric towards the y. So no symmetry. Is my function decreasing? No, it's only actually steadily increasing. It's increasing from 0 to infinity. It has a local maximum and a local minimum. It actually has a minimum at y equals 0. And an absolute minimum at y equals 0, right? The point. The lowest point of this is 0. That's it. That's the absolute minimum point. There is no absolute maximum. There's only minimum. There's a local minimum at y equals 0, and there's an absolute minimum, which is at y equals 0. And that is the square root function. Okay. Be careful with this. No negatives inside a square root. So that's when you have just the square root of x, okay? The domain. Okay, we'll move on to the cube root function. The cube root function is, if I'm plugging in the values of x, y equals the cube root of a -8, that's a -2. When you plug in a -1, you get -1. When you plug in a 0, you get 0. When you plug in a 1, you get a 1. When you find the cube root of 8, you're gonna get 2. So all you're doing is you're substituting these points into x, and then you're getting your output. So when I plug this in, this is -8, -2, -1, 1, 0, 0, the 0.11, the 0.82. So this looks like a snake. That looks like this. Okay. So it's, the domain is from left to right, -infinity to positive infinity. Your range is also from -infinity to positive infinity. There is an x-intercept here at 0, 0. Then you have the x-intercept and the y-intercept both to be 0, 0. It's symmetric towards the origin because this is an odd function. How do I know this is an odd function? Y equal the cube root of x is the same as x to the 1/3. This is an odd function. Where is it decreasing? Is it ever going down? No, because you're starting from left to right. This looks as if this was steady, but no, it's actually always increasing. It's always increasing from negative infinity to positive infinity. And then there's a local minimum point right here at 0, 0. There is no absolute min or max because of these arrows right here. This is not a closed interval, so it keeps on going. There's no absolute maximum. There's no absolute minimum. That is for the cube root function. Any questions so far on any of the ones that we've done? We've done the identity, the quadratic, the cubic, the square root. Now this is a cube root function, and then we're going to move on to, this is called the reciprocal function, the 1/x business. When we plug in -2, we get -1/2. When we plug in a -1, we get -1. What happens when we plug in a 0? It does not exist. You're not allowed to be 0 on the denominator. When you plug in a 1, you get a 1. When you plug in 2, you get a 1/2. So how would you graph that? It looks like this. So it's going to be 1, 2 and 1/2, 3 and 1/3, 1/4. Notice this is going to go to 0. It wants to go to 0. So you have this behavior. Now -1, -1, and it looks like this. So at x, so the domain is everything but 0. So x such that x cannot equal 0. Or you could say this, from -infinity to 0, union from 0 to infinity. I'm excluding the 0. Also the range, notice how the lowest value, so you can be everything, but you're never going to be 0. So it's the same. It's from -infinity to 0, union 0 to infinity. So both the domain and the range are the same for the reciprocal function. The x-intercepts, you don't have one. There is no x-intercept. There's no y-intercept. There is symmetry towards the origin right here. There's symmetric towards the origin. The function is decreasing from -infinity. So see how it's from -infinity, it goes down. So this one's also always going down. It's actually always going down. It's going to go down from -infinity to 0, and then again union from 0 to infinity. So this is it's always decreasing. The function is never increasing. You don't have a local min and you don't have a local max. So this one's special. This one's called the reciprocal function. Okay. So you're learning all these types of functions because we're going to do things with these functions in a moment. Okay. We do have the absolute value function, which we are kind of familiar with that. The absolute value of a -2 is a +2. The absolute value of a -1 is a 1. The absolute value of 0 is a 0. The absolute value of 1 is a 1. The absolute value of 2 is a 2. So we graph that like so. And this is a V shape. This looks like a V. So this one, the domain is all real numbers. You're allowed to be anything from left to right. Now be careful because the range is the lowest point. The lowest point is at 0 to infinity. My x-intercept is at 0, 0. My y-intercept is at 0, 0. This is symmetric towards the y-axis. Why? Well, because it's even. Okay. This is an even function, so that's symmetric towards the y-axis. Now, where is it decreasing? It's going down from here to here. So from negative infinity to 0, it's increasing from 0 to infinity. There is a local maximum right here, sorry, a local minimum at 0, 0, and an absolute minimum at 0. Again, at y equals 0. So it's gonna be, there's no maximum because it goes to infinity. Okay, but there is this minimum value, this absolute minimum or local minimum at y equals 0. Okay, that was the absolute value function. I think that the next thing is, okay, we have one more, I think. And then we're gonna go on break and then, excuse me. And then we'll move forward. So the constant function is the one that's always constant. It doesn't change. Is this y equal b line? B can change. B can be 1, 2, 3, 4. It doesn't matter as long as it's constant. These graphs will always be constant with the y-intercept of b. Okay. So this one's simple because you're always the same. You don't have any, the y-intercept will be y equal b. You don't have increasing or decreasing. You're always constant. Now, I want to talk about this greatest integer function. This 1.3, it's the integer. It's closer to which integer? 1. The greatest integer is less than or equal to the number. So 1.3, even 1.7, the closest integer, the greatest, the less than value is 1. So you always go back to the integer. So if you're -1, you're the same. If you're -0.5, you're -1 because it's less than the original value. -1/4 is less, this -1 is less than this -1/4. These all have the same y value because we're looking for the closest integer value. So the integer value closest to -0.5 is -1. -1/4 is -1. So you always go less than that. So notice how this is 0, the integer is 0. 1/4, it's 0. 1/2 is also 0. You'll say, well, 1/2 is closer to 1, but I want to look for the one less than that. So 3/4 is also 0. 1, the integer is already a 1, so it stays the same. 1.5 is also 1. 2 will be 2, 2.7 will be 2, 3 will be 3, 3.2 will be 3. If I would add 4.3, what would be the integer closer to that one? What would be the answer?
4.
Yep. And what if it would be 4.8? What would the answer be?
5.
Be careful.
Oh, 4.
The one less than that. It'd be 4. When is it going to be 5? When the integer is 5 or 5.5 or 5.6. So it's always one less than that. That's called the greatest integer function. So Michael, were you able to catch that?
Yep, got it.
Okay. So then how do we graph that? These are called step functions. They look like little steps. So here we have from -1 to 1. So -1, -1, -0.5, 1. Here at -1. At 0, we're now at 0. And then at 1/4, we're at 0. And then 1/2 right here at 0 too. When we get to 1, we're now here at 1. So 0.9999999, it will still be 0. Do you see that? So unless we get to 1, so we have another point right there, another point, another point, another point, another point. This is called the step function. So the greatest integer function is actually a discontinuous function because it jumps. So see how there's more than one value that matches an x? That tells me that this is a discontinuous. There's a gap. So now from here to here it jumps, from here to here it jumps, from here to here it jumps. this is not continuous. There's a jump of discontinuity. It's not smooth. Right? There's gaps. That's a discontinuous function. So now we're going to get to the good part, which is called the piecewise functions. We'll do this, and then we'll have that, and then we'll go to 1.5. So we'll talk about piecewise functions next. So what we're going to do